To discuss this problem, you were asked to find what's the derivative of z with respect to q. Well, some of you don't feel comfortable with this basic structure, so one thing I encourage you to do is to convert the notation into something that you feel comfortable with. So you could have said this problem is y equals x times pi to the power of cosine of x. Some of you even don't feel comfortable with the notation of pi, which actually is a constant. So what you could also do is you could have written it into something you like, but just make sure when you finish the calculation, you convert pi 2 back to pi, x back to q, and y back to z. Right, so well, if this were my problem, and it's quite obvious, the last step of calculation is product. So when I try to find the derivative, I'm going to use product to do the calculation. So this is what I end up with. So I have 2 cosine of x takes derivative. Well, 2 cosine x clearly is a composite function where you had 2 to the x with the cosine of x substituted in. So you will be using chain rule to solve the second half of it. X prime equals 1. And then you end up with x times, well, chain rule, you differentiate outside layer 2 to the x first, so it's 2 to the x times ln of 2, and then you substitute the inside layer, and then you take the derivative of your inside layer. So your final answer is 2 to the power of cosine x plus x times twice 2 to the cosine x times ln of 2 times negative sine of x. But of course, don't forget what we said earlier. This is a problem that we changed and solved, right? So you want to make sure you answer your question in the original structure. So you convert everything back. It's saying z prime is pi to the cosine of q plus q times pi to the cosine q times ln of pi times negative sine of q, right? Every single x is now went back to be called q. Every single 2 is now went back to be called pi. So this is the final answer of my question.